Welcome to The Explainer. Today, we're going to break down something you probably do every single day, connecting your favorite apps to services like Google or Facebook. We're going to look at how it all works securely without you ever having to share your password. Let's get right into it.
Okay, you've definitely done this a million times. You hit login with Google and you get bounced over to Google. Then you click allow and boom, you're sent right back. But did you ever stop and wonder what that whole dance is about? Why is there that extra step? And what's with that super long string of random characters that flashes in the address bar? Well, that little temporary code is the key to the whole thing.
To really get what's going on in this digital handshake, which has a fancy name, the Authorization Code Grant, we first need to know who's who in this little play. There are 4 key players on the field.
First up, and maybe the most important player, is the resource owner. And yep, that's you. You're in the driver's seat. It's your data, and you're the only one with the power to say yes or no to an app that wants to access it.
Next, you've got the client. This is just the application. Think Yelp, or that cool new productivity app you just downloaded. It's the one asking for permission to do something useful for you, like maybe read your Google Contacts to find your friends.
Our third player is the authorization server. You can think of this one as the official gatekeeper. It's the service you actually trust with your password, like accounts.google.com. It's the one that handles your login, confirms you're okay with the request, and then issues the keys.
And finally, we have the resource server. This is the vault. It's the secure API where all your valuable stuff, your photos, your contacts, your emails, is actually stored. It's what the client is ultimately trying to get access to.
Okay, now that we know who's who, it's time for Act 1. And what's really interesting here is that this entire first part of the process happens right out in the open, right there inside your web browser.
It all kicks off the moment you click that Connect with Google button. Immediately, the app sends your browser on a little trip over to the authorization server, in this case, Google. And it carries a little message saying exactly what permissions it wants.
So now you're on Google's turf. You log in, you see that little consent screen asking, hey, is it okay if Yelp sees your contacts? You click allow. Then Google immediately sends your browser right back to the Yelp app, but with a special little gift in the URL, that temporary, one-time use authorization code.
Now this brings us to an absolutely crucial idea. Everything we've seen so far happened on what's called the front channel. Think of it as a public space. It's your browser. It's great for you to interact with things, but it's not super secure. The really sensitive transaction is about to happen in private, on what we call the back channel.
Okay, so let's move behind the curtain and onto that back channel. This is where the real security magic of OAuth 2.0 really comes to life.
So completely hidden from your view, the client server takes that temporary code it got from your browser. It then opens a direct, private, server-to-server connection to Google's authorization server. It says, hey, here's that code the user just gave me, and to prove it's really me, here's my secret key. Google checks both, and if it all looks good, it finally hands over the real prize, the powerful access token.
Which, of course, brings us right back to the big mystery, right? Why go through all that hassle with a temporary code if the goal was to get the access token all along? Why didn't Google just send that back to the browser in the first place?
And here is the absolutely brilliant answer. By using that temporary code as a go-between, the whole process guarantees that the powerful, valuable access token is only ever sent over the secure, private back channel. It never, ever, ever touches the less secure front channel of your browser.
And this separation is everything. Seriously, think about the risks if that token was in your browser. A malicious extension could just snatch it. It could get saved in your browser history for anyone to find. Heck, someone could literally just look over your shoulder and copy it from the address bar. But that temporary code, it's basically worthless to an attacker. It's only good for a few seconds, and even if they grabbed it, they still need the client's secret key to do anything with it.
So, the secret handshake is complete. The key has been securely passed. Now, the client finally has what it needs to do the job you gave it permission to do.
With that powerful access token in hand, the client can now make those direct, secure, back-channel calls to the resource server, the vault. It presents this token kind of like a valet key. It proves it has your permission to access only the specific data you approved, like your contacts, all without ever needing to know your master password to the entire system.
And there you have it. That's how this clever little dance between the public front channel and the private back channel keeps your digital life incredibly secure. But you know, it does raise another really interesting question. How does the resource server actually know that the token itself is legitimate and hasn't been faked or tampered with? Well,
Okay, deep breath. Let's put all of these pieces together now. We're going to walk through the entire flow one last time, from start to finish, now that we know all the secrets.
All right, here we go. Step 1, you kick things off on Yelp. Step 2, Yelp redirects your browser over to Google's authorization server. This all happens on the front channel. Step 3, you log in, you give consent. Step 4, Google server sends that temporary authorization code back to Yelp, again, through your browser on the front channel. Step 5, now things get serious. Yelp uses the secure back channel to send that code plus its own top-secret client secret directly to Google's server. And finally, Step 6, Google verifies everything and sends back the powerful access token, still on that secure back channel. And now, Yelp has the key it needs to access your contacts.
At the end of the day, it's just an incredibly elegant design. The flow is built to take advantage of what the front channel is good for, interacting with you, the user, and what the back channel is good for, which is passing sensitive credentials around in a way that's highly, highly secure. So the next time you click Log in with Google, you'll know all about this clever and secure dance that's happening just out of sight. And it makes you wonder, doesn't it? Now that you can see this elegant solution, this careful balance between front-facing convenience and back-channel security, where else in our digital lives do you see this exact same trade-off happening?